Hello guys, welcome back to my channel, Memo African Motives. Still working on mathematics N2. So in this platform actually shall have a continuation on our daily online classes that is working on trigonometry, which is the 7th class that we are having. So guys, if you are new, you can consider subscribing so that you become part of the family, Memo African Motives. So on trigonometry, actually it's a very important topic that you're supposed to understand. So in this platform we shall work from the basics of trigonometry, what you need to know, the basics, and depending with the time we'll see what you're going to have next. So when working with the trigonometry, the best thing that you need to do is to understand the concept of trigonometrical ratios. Okay, so there is what you refer as the trig ratios, which is actually the trigonometrical ratios. So these are ratios which are generated or which can be formulated or can be taken from a right-angled triangle. So I'm going to talk about a right-angled triangle, what we have on this right-angled triangle, and I'm going to represent this right-angled triangle on a Cartesian plane later on. So from a right-angled triangle, let's say this is the angle that you're talking about. So the angle is theta. So theta is just it's just a Greek word, that one. So just like X, Y, just from the Greek alphabet. Okay, so nothing to worry about. So given a condition that this is your theta, it is going to determine the sides of the triangle according to this angle. So this side which faces the angle here becomes the opposite. Okay, so this is the opposite side, and this side where there is the angle and the theta is what you refer to as the adjacent, the one that is with the right angle. These two sides, they are adjacent, they are on the same side, like this. All right, this is the side, this is the point, they are on the same point or on the same side, so they are adjacent to each other. All right, so now how am I going to connect these dots now? How am I going to connect? We have got the hypotenuse here, which is the longest side that we are going to have. So the idea that we need here is to connect these ratios, to formulate the ratios from these sides, opposite, adjacent, and the hypotenuse. So you are going to be held by these mnemonics, that's soccer, Tor. So you're going to be helped by this, where we can formulate the ratio for sine theta, which is sine the angle theta, as opposite over hypotenuse. So technet, it's opposite over hypotenuse. So you can just write this as opposite like this, over hypotenuse. You can have the trig ratio for cos theta. So it's cos of the angle theta, which is equal to adjacent over hypotenuse. So this is going to be adjacent over the hypotenuse. From tan, you can formulate tan theta, which is the same opposite over adjacent, like that. So that's how you formulate these ratios. Okay, so in addition now to these ratios that we have, which is actually, let's just say 1, 2, 3, there is what we are going to have, which is the fourth one, where we are going to have 1 over sine theta, like this, which is going to give us what is called cosec theta. Take note, guys, 1 over sine theta cosec. So it opposes like co here, 1 over sine, but it's like cosec. Okay, 1 over cos theta, which is co, is going to be sec. So it's going to be sec theta, 1 over cos theta, which is sec theta. So sec is 1 over cos, so you're supposed to know this part. Okay, then tan theta, 1 over tan theta is going to give us cot. So this one is cot theta. Take note. So that is what you're going to have. And also it is important to note that from the same tan theta, you can write this tan theta in terms of sine and cos. So tan theta can be given as sine theta over cos theta, like this. All right. So as we can see, these are the major and important trigs that we are supposed to work with, or to understand, or to know how you are going to determine or to calculate whatever that you be given in this platform. All right. So now, due to the understanding of this part, how you're going to be working with it depends whether you're working with this on a quadrant or whatever part that you'll be working with. So we are going to also talk about the relationship that you have when you are given quadrants. But for the meantime, let's say you are given a right angle triangle. Now it's like this. This is A, this is B, and this is C. That's a right angle triangle. And you are given the sides 4, 3, and 5. All right, then the question is to find or to calculate. Find the values of, all right, let's just have tan A. Another one, let's have sine B. Okay, another one, let's just have even cos B again. It's not a problem. And also we can just have another one, maybe sec A. All right, like that. So what are we going to do from this information, guys? These are angles. A is an angle, B, we are referring to angle A, angle B. Okay, so we're asked to calculate the value of tan A. All right, so where are we going to have the value of tan? Remember, from the ratios that we talked about from our soccer tour, guys, tan is opposite over the adjacent. So we are going to have opposite over adjacent, which is according to the angle A. This is your angle A here. So according to this angle, this is the opposite. According to this one that is opposite, close, like the one that faces A, this 3. So it's the opposite, and the adjacent, where the angle and the other angle are lying on. So they are lying on this line. So it's 4. So it's opposite 3 over the adjacent, opposite over adjacent, which is over our adjacent, which is 4. So we have got the value of tan there. All right, then another part is to calculate the value of sine B. All right, so sine B, still we have the same thing, which is the ratio for sine opposite over hypotenuse. So we're just going to substitute that's our opposite according to B this time, because this is sine B. So you're now referring to this angle B. This is your angle now that you are working with. So according to this angle B, this is now your opposite. As you can see, this is the one that is opposite to B, which is your opposite is 4 according to B. So your opposite is 4 over the hypotenuse. Remember, the hypotenuse does not change, and our hypotenuse is 5. No matter the angle that you use, hypotenuse does not change. All right, then another item was to calculate cos B. Same, so cos here is adjacent over the hypotenuse. All right, so what is the adjacent according to B? This is angle B, so this becomes adjacent, because where you have angle B and 90 degrees, these two, they lie on this line. So this is our adjacent now, which is 3 over the hypotenuse does not change, which is 5. All right, and then on item 4, we needed to calculate sec A, which is sec of this angle here, sec A. So where are we going to have sec, guys? Remember, we said sec is given as 1 over cos. So this sec A is going to be 1 over cos A, just like that. So you just need to calculate cos A, of which we do not have the value of cos A here. So you're going to find the value of cos A first. Okay, sorry, I don't know why is this thing shaking like this. Okay, anyways, let's find the value of cos A. We didn't calculate this, but we can calculate because we said cos is adjacent over hypotenuse. We talked about this here, adjacent over hypotenuse. Okay, so according to angle A, this is your angle A, the adjacent is this side because this angle A, remember the angle and the 90 degrees, this is according to angle A, this is your adjacent. So we've got 4 over the hypotenuse does not change, which is 5. So this is 4 over 5. So we are going to have 1 over cos A, which is 4 over 5, like this, because the value of cos A is 4 over 5. So you are going to insert in place of cos A, you substitute 4 over 5. In place of cos A, you substitute 4 over 5. So if you are to simplify this using your calculator, you are going to obtain 5 over 4. So this is the value of sec A, which is 5 over 4. So that's how they ask these questions, guys. As you can see, it's simply something which is straightforward, like this part you're given the triangle, then you're asked to calculate tan A, tan D, tan E, whatever that should be given there. So as you can see, it's a matter of working with the triangle. You can calculate all these. Sin G, you just know it's opposite of hypotenuse, that's 5 over 13. So that is what is actually happening here. So you can have your triangle, they will give you a triangle like that, they ask you to calculate the tan or cos. That is what you're going to do. Okay, so now I want you to have an understanding when you are going to refer to this on quadrants. We are going to have this actually as a continuation in our next class, but I want you to have a clear understanding now when you are working with quadrants. Okay, so what happens is that each quadrant has got a ratio which is positive. In each and every quadrant there is a ratio which is positive. So how am I going to know which ratio is positive in this quadrant? We are going to use this concept. All students take calculus, like this. All students, this is how you name in this direction. So this is the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. That's how you take it, like this. So quadrant means we've got 4 equal pieces, 1, 2, 3, 4. That's a quadrant. Okay, so all means all acute angles, they are positive. So this is for sine, cos, tan. Sine is positive here, cos is positive, tan is positive here, because we are talking about all the 3 trig ratios, which is sine, cos and tan. But in the second quadrant, it's only sine which is a positive, which means cos is a negative, tan is a negative, because sine is the only one which is positive. In the third quadrant, it's only tan which is a positive. In the fourth quadrant, it's only cos which is a positive. So that is the idea there. So cos is positive in the fourth quadrant, tan is positive in the third quadrant, sine is positive in the second quadrant, but all of them, they are all positive also in the first quadrant. So it means if cos is positive, sine is negative at that moment, tan is negative at that moment. If tan is positive, it means cos is negative at that moment, sine is negative at that moment. Same as what I said here, but here all of them, they are positive. So there's nothing that you're going to do or to interchange there. All right, so that's the condition that you're going to have on quadrants. Just know that this is x and y, and we are going to talk more about how do you calculate or how do you determine angles in each and every quadrant. Okay, so we talked about this. Then we are now going to talk about angles in each quadrant. So each quadrant can be represented by a certain angle. Each quadrant can be represented by a certain angle. Okay, what do I mean? In the first quadrant, this is what you're going to have. if you are to draw a right angle triangle like this, okay, we're going to have a right angle triangle like this. This is the angle that you're going to take. So as you can see that this angle that you are having according to this triangle, like you are having something like this, this is, remember, this is your x-axis and this is your y-axis like this. So as you can see on this side, our x is positive this side, on top here y is positive, so x is positive, also this one is positive, and this is also positive. So x is positive, y is positive, like that. So that is why you see that all the ratios are positive, because of the quadrant that we are in. That is how you take this quadrant. Okay, so in this quadrant, if this is your theta, this is positive. So let's see what I'm trying to say. If you are to find, let's say you want to find sine theta, you're going to have sine theta, remember it's opposite over hypotenuse. So as you can see, it's a positive y over the hypotenuse, which is r. Cos theta, which is the same, is adjacent over our adjacent is positive, so it's x over r, like that. Tan theta, it's opposite over adjacent, so it's y over x. So as you can see, they're all positives. That is why we said in the first quadrant all angles are positive. But if you are to cross check, so this was actually the first quadrant, so all angles there are actually positive, all ratios that you're going to have. What about in the second quadrant? Let's represent in terms of these angles now. What are we going to have in the second quadrant? So in the second quadrant, this is how your triangle is going to look like. It is going to look like this. Your triangle is going to look like this, okay, where this is a 90 degrees. As we know, this is x and this is y. So this time x is on the negative. We are in the negative here, so this is going to be minus x. Okay, y is still above the line here, it's on top of the x-axis, so it's a positive, so y is still a positive, and this is r, which is the resultant. So as you can see, this becomes your theta here, and this angle, since we know that angles on a straight line add up to 180, this is going to be 180 degrees minus theta, like that. All right, so if you are to cross check in the second quadrant, we are going to see that sine, just like we talked that this is for sine, and sine is going to be positive. Let's see if this is true. Sine theta is opposite, which is, as you can see, our opposite is a positive, so it's opposite y over the hypotenuse, which is r. So as you can see, it's a positive, and we said if this is a positive, tan is going to be a negative. Let's see if this is true. Tan theta is equal to, remember the ratio for tan, we said opposite over adjacent. So your opposite is positive y, like this, over your adjacent is minus x. So as you can see, our answer is having a negative. Okay, the same with cos theta, it's adjacent over hypotenuse. Your adjacent is minus x over hypotenuse, which is r. So as you can see, it's also a negative. That's why we said in the second quadrant, it's only sine which is a positive. From this concept, it must make sense now from this concept that in the second quadrant, it's only sine which is a positive. So it's the same thing. Tan in the third quadrant is the only one which is going to be a positive. Cos in the fourth quadrant is going to be the only one which is going to be a positive. So how do I draw now a quadrant? How do I draw the triangle in the third quadrant? So this is how your triangle is going to look like in the third quadrant. It's going to be like this. All right, this is your triangle. Always the triangle is supposed to be joined to the horizontal. Okay, so this is how it's going to look like, and this is your theta, and as you can see, our x is still in the negative. Our x is a negative, so it's negative x, and y now is now below this line. As you can see, it's below this line, so which means it's now a negative. So you're going to have negative y like this, and this is your r. Okay, so as you can see, that's how it is going to look like, and the angle now is going to be this one added together. That's 180 plus theta there. But according to this, if you are to cross-check, tan must be the only one which is a positive, because we said all students take calculus and this is the quadrant for tan. So let's just prove, is that so? Tan theta, it's opposite over adjacent, so opposite minus y over adjacent minus x. So negative and negative can cancel, which is going to give us y over x. So that's true. So let's prove also for sine. Is it going to be a negative, because tan is the only one which is a positive, which means sine and cos, they are negative, and sine theta is opposite over hypotenuse, because this is where your 90 degrees is. So this is opposite minus y over hypotenuse, which is r. As you can see, it's a negative. Let's also prove for cos theta. It's going to be adjacent. This is your adjacent over hypotenuse. So adjacent, it's minus x over r. As you can see, it's a negative. So that's why we are saying tan is the only one which is a positive, which is true. Okay, let's prove also for the last quadrant, which is the fourth quadrant, using the same information. So this is the fourth quadrant now. All right, so in the fourth quadrant, remember, your fourth quadrant, this is the last quadrant here. So your triangle is going to look like this, guys. This is how your triangle is going to look like, and that's your theta. So as you can see now, we are back. Our x is on this side, which is a positive. This is your x, this is your y. So your x is now on the positive, your y is the one which is on the negative, so it's negative y, and this is your resultant, guys. Okay, something like that. Take note about the diagram there. So that's your fourth quadrant, and in this quadrant, all students take calculus. It's only cos which is a positive, like we said. So which means, let's prove, is this cos going to be a positive? Cos theta, remember, is adjacent of hypotenuse. According to theta, this is our adjacent, because this is where we have our 90 degrees here. So that's your adjacent x, which is a positive, over the hypotenuse. Hypotenuse is always a positive, whether it's on this region, or it's on top. Hypotenuse is always a positive. Okay, then let's see for tan. So as you can see, it's true because it's a positive here. Let's see for tan theta. Tan, it's opposite over adjacent, so opposite, it's minus y over the adjacent, which is x. So as you can see, it's a negative, and it's true because tan is supposed to be a negative. If only cos is positive, which means tan should be a negative there. Let's prove for sine. Sine theta also, sine is opposite over hypotenuse, so it's minus y over the hypotenuse, which is r. And as you can see, it's also a negative. So cross-checking and seeing this, you will come to conclude that that quadrant concept is actually true, and it means whatever that we talked about in terms of the angles being positive or being negative. So that is what you're going to have there. So as a conclusion, you can actually have this now in terms of quadrants. So this is what you're going to have from each quadrant there. So this is the quadrant, the range. So sine, remember, sine works with cosec, cos works with sec, tan works with cot. So in the first quadrant, that's for all between 0 and 90. So sine is positive, cos is positive, we said all they are positive. Okay, in the second quadrant, that's for sine, where we said only sine is positive. That's from 90 to 180, which is like this, guys, from 90 to 180. As we can see, that's a sine being positive, as I said, which means cos is negative, tan is negative. Then in the third quadrant, we said it's tan which is positive, and that is the range, the interval that you're given. And in this, tan is the only one which is under tan, that's why tan is a positive. In the fourth quadrant, this one is for cos, and that's the interval between 270 and 360, and it's only cos which is positive, so that's why only cos is positive. sine is negative, tan is negative at that moment. So I think that's how you're going to memorize this. Okay, so in the quadrant 1, quadrant 2, quadrant 3, and so forth. So that's it, guys. Trigonometry on the first part that we had. So we're going to have a continuation now on the application of whatever that we're talking about, because this is not enough. We need to apply this information also. You must also understand how to use the Pythagoras theorem, which is actually a direct part. That is, no, we are just going to apply it in our next class. So that's it, guys, from Mason African Motives. Till we meet again.